done by me and a lot of it's by Yoann since as we worked together for a few years at B1. But really, oh, and it's not working. But really, I have to add a lot of people because basically this is a result of me writing MATLAB since my first internship doing my Master of Engineering with Xavier. I'll come to it. So anyway, what is CoFFee? I think I'm going to clear up a few things because people were confused at the title of my talk. And I realized that I have never really talked about it because it was so messy that I never really shared this with. But CoFFee is basically my library of MATLAB functions that I've been writing as a repository for all the code I wrote on all my time from my first internship and with all of those people. And that's why they're all basically called about this. And the idea is like basically every time I do something in MATLAB, I just like put it in it. So it does a range of things, including GIS, working with digital regression models. But most of it is for working with sonar data. So the status, as I say, it's really messy, and that's why I really never really talked about it because I'm basically the only person who can use it, as I guess a lot of people like to start with. And at some point, you say, okay, I'm going to try to clean it up a little bit so that other people can benefit from it. And I've been doing it since Deakin University. So increasingly, I've had like people working with my CoFFee since it was starting getting usable. Still need a lot of my input to get things to work. But anyway, my objective is to try to get a cleaner version 2 that's usable by other people. And it's kind of like getting there. So I'm currently into pre-release. So it's pretty slow because this is not my main work. That's not the one I'm supposed to do. So I'm trying to do this side. But the basic philosophy behind is to have a library of function. So this is what we do. To try to build a library of function for scripting command line use. But on top of which you can actually build like a few apps, ideally light and small, like for single purpose. Most importantly, it's also open source. I am on MIT license. Some problem before I go into it. The first one is that it'll still be messy. I'm not going there trying to write a fantastic library that's like bug-free that's supported. That's not the plan. So I'll still need my help. And because this is like things that have been built, it's pretty slow and relatively unoptimized, but though some efforts have been made in that aspect. So just to say, it's not going to replace any commercial software. So it's not going to replace anything. The other issue is that it's in MATLAB, so it means that you need a license for something. But as we've seen, like Peter ran a project because I know that this one since I'm involved with Peter, but I didn't know that we have intention to work with it. So obviously, you guys are going to make my work obsolete at some point very soon. It would be great. Anyway, the advantage is that it's pretty good for students who need an existing code collection to perform the basics, and then they can explore their data or build their things. So that's a paper. The first paper from Amy Now's PhD, she's at University of Tasmania, BCSIRO, and she's been like working on trying to detect gas flares in the data. So she reached out to me. She was using V1, so it took a lot of time to just get together, and we sent her a lot of work with V1, so she has a bit of a mix. Now, if she were to redo this with what we have now, I mean, it would have saved a lot of time. I won't run through this because it's a bit, I don't have that much time. I just wanted to show in a few scripts in excerpts of one script that's showing that in a few lines, you can basically convert your data, extract your water column, display it in the wedge display, and most recently I've been working on doing that stacking range and depth so that you have an FFG. And all of this are just like on the script, which is like 61 lines, and most of which is about display. So it starts getting to the point where I can do the basics like relatively easy. All that stuff is open source. It's on GitHub under my name. CoFFee, and there's a bit of a README5 to explain how to start using it, but you can go right away if you have a MATLAB license. As I was saying, the other advantage is the fact that MATLAB makes it extremely easy for people to actually build up, even for people who are like amazing software designer. That's absolutely nuts. And the other advantage in this is that if you have the proper license on my side, they can basically compile those applications into a standalone desktop app that people can use without using an address. So you're not using the code, you're using the app version, you're not paying for everything, it's all free. You just have to install the MATLAB runtime, which is like a free piece of software that actually can run this. And I've built 3 apps based on CoFFee, and you'll see the theme in terms of the names. First one is called Grounds. It's about visualizing and analyzing change between digital elevation models. I won't talk about this because it's not about Backscatter, but it's open source, so you can go straight away and download either the source code or even the compiled version and run it on the computer that you run. That could be of interest for people into geography. It's all about like implementing the methods I have designed for computing uncertainty of the volumes of change between. The next one is called Espresso, and that's the one that designed with Yoann at Ladroit to visualize and analyze multibeam water column data. So this one, unfortunately, is not open source. I'll talk about it later. And the other one that some of you were also at Ierodiaconou seen me talking about the Cafe, the latest one, which I've worked since I'm at M.F.J, and the point is to visualize and analyze the quality of multibeam seafloor Backscatter data. This one is open source. This one's been also compiled, so it can be installed on the computer right away. So talking about Espresso, so again, it's to visualize and analyze multibeam water column data. Running switch really quickly, so it was built when I was at NIWA, and it is still NIWA proprietary, even though with Yoann and NIWA, we kind of trying to talk to see what can be done here to either make it open source or at least to allow partners to use it or something. So I mean, it's of commercial interest to NIWA, so they are not too much in a hurry to actually see that it's not the idea, but we'll figure something. And also the reason why I never really talked about it, even though I've used it in Vegas. But basically, I have to give lots of praise to Yoann. I think if you remove the CoFFee parts, like most of Espresso would actually be done by the majority of it. Yoann is a matter that he does when I was at Texas. So it supports Kongsberg formats, so that's all the WCD, and to some extent, Camel and S7K. And basically, with it, you convert, load, and visualize the water column data. Apply some filter or masking the data that you're not really interested in. And then apply some grading, so vertically, what they call eco-integration, to allow you showing the hotspots like on the map, just like what Peter was saying. I came up with that before being told that Sonarscope was actually doing it, so let's say mind. But yeah, the idea is like basically, of course, you can parameterize what part of the data you want to actually integrate. That's not being masked. Yoann also coded to do it in 3D, so you actually do like slice by slice. So you actually basically run through every size of the column to try to find the targets of interest. It comes up with some feature to do some geo-picking so that you can find the things of interest on this map and export them. And also mosaic all your lines together and export the results as a geotiff in order to use some. This software we used twice. So one is a paper by NIWA, so with Yoann that I'm not part of, and another one that Peter was coming just after me is going to present. Where basically the idea is we use this to eco-integrate just the 1 meter layer just above the seafloor to see if it had a trace of the entrance of macroalgae on the water column, and trying to see if that product could be useful for habitat mapping. And I won't spoil the results. So moving on to this cafe, so that's the one that you saw at your hub. It's to check and assess the quality of multibeam seafloor Backscatter. It's built at M.F.J. It's being built right now. I'm not much progress on it since you have. And it's mostly for supporting. I'm building all around Kongsberg.org formats because that's what we have at the most. But I hope to be able to push it in formats, and it's being actively developed. The reason behind this cafe is that at NGU, we have a lot of our data obtained by contractors from the Mariano program. And as we say in our tenders, the data are considered unusable where they are dominated by noise or other artifacts which obscures natural variation in the acoustic reflectivity of the seabed. So it's super, super important, but it's a really, really fuzzy definition of what is usable and what is unusable and what's the level in between. And at which point can you tell your contractor, hey, that's not enough, you have to go back and acquire metadata. You know, it's a really complicated topic for a lot of because the kind of problems that you have in your seafloor Backscatter, there's like a whole range of them, and maybe different degrees at different places, but that's the kind of issues that we've had from the data that we receive from contractors with raised eyebrows when we see them. And we know that this problem is not limited, I mean, this concern is not limited to us, and we talk to it. So the idea for NGO is say, okay, is there any way that we can kind of quantify what is the quality so that we have common ground to talk with our contractors about what quality is sufficient? So showing a little bit what this cafe does at that stage is to convert your raw files. We can load them, source them, display the really Backscatter data, bathymetry, slope, and mode of acquisition. And before anyone think of it, this won't replace FMPD. The quality of this thing in terms of the modeling is not up to par with the information software. So this is meant to explore the quality of the Backscatter data. It's not going to save you the money on your modeling software. So, so analyzing the Backscatter quality, I'm trying to do it at two levels. Basically, the first level is to do line by line to see the problems that are on the line basis. So for example, on a given line, you get some information already from in the raw data. It tells you which sound is attached in yellow here, and then trying to come up with some algorithm to say, okay, what pings are obviously wrong, and you have quite a classic example of when you have bad weather affecting your data. As you can see from this, my algorithm still needs to be improved quite significantly. But I'm trying to get the general idea there before fine-tuning the algorithm, obviously. And most importantly, the idea is to produce metrics from it. So, for example, per line, actually get percentage of the bad sound in the line, or the percentage of bad pings in the line. That's the sort of information we're trying to extract from the data, like quantitative information. And this data, this kind of metric can be produced for each line, and then overall for the entire data. The second level is to work on an area, because there's the basic idea that you can have, say, a line with lots of bad data in it, but then you notice it's lots of bad data, so you get a patch to cover it. How do you tell that the patch data successfully fixed the problem that was found? So one easy solution is to work on an area base, so define the area where you want to analyze the data of, and then from there you basically analyze where are the gaps in the data, where are the grid cells that only have bad data on it, etc. So for now, all I do is like finding where you have gaps, which basically correlate that based on like the percentage of the grid cells that are actually missing. But the basic idea as well is to report it. So you can export this analysis results. So for example, I can export those the bad area as a TIFF. The idea being that if the contractor is on site and find that he has bad data, he can export this, load it into his survey file, and just like double check that he has the data everywhere, and export the results of analysis results as well. And all of this ideally would like provide some common ground. But first, some common ground so that we can agree at the tender contracting stage with the contractor to say, hey, that's the kind of data quality we want or whatever. But this won't get to that stage until it's at the good condition. But it's already useful because we've already sent the software to one group that we're doing some survey, which actually found it useful to start spotting the issues in the data. So some comments that still at a very early stage of development, meaning he has few features and a lot of work. And in particular, it's limited to the convert but all formats for now. It cannot handle a lot of data. I have a lot of memory management to improve, and that's not an easy one to fix because it's depending on my previous choice. So that data, again, not a software developer. And then the data analysis algorithm needs still major improvement and tuning. Biggest problem I see is that there's a lot of bad data which are going to be difficult to quantify and to figure what metrics are created. The idea is that it's built for our needs, but because it's open source, I cannot see it also as a possible platform for the community to discuss and agree on standard metrics of Backscatter. If you have this sort of problems with your data or your contractors, you want to use this, use it on your data, we can talk about the kind of problems we have, and the idea is like all together, we could basically come up with a set of metrics that seems to be working more or less universally for everyone. That's what I hope. The following is completely hypothetical of how we could use this or build use this to get together to build some standard of quality. You can have some metrics and rate them, give them some rating about how the quality of the Backscatter in respect to that metric. And basically say, oh, if I have 0.8% bad cells in my grade, then my standard is this. It's basically trying to come up for a lot of different metrics that you can imagine. And every time basically rate your data set according to that metric. And at the end of your work, you basically take whichever was the lowest rating, and that's your rating for. So this is not implemented in this it's just an idea of how things could work. And then you go to your contractor and say, hey, I don't want any data set that's less than good. And if they have this when they're on the field, they can actually run that thing. So if their data set is actually of bad quality, they have the possibility to improve on it before the code. And finish, I only have 2.5 minutes. Some food for thought by the Backscatter working group. So completing a few ideas that I discussed before for those of you where like they have the online group. The idea is a lot of people talk about it. So all of this is basically how I see Backscatter working group version 2 get organized, but all food for discussion. The way I imagine it is to have branches, as we discussed it before, which are basically led by 1 or 2 people on some things. And the idea is that their work would be to actually seek relevant projects outside of the Backscatter working group, because all of us actually are working on those topics in our respective institutions. Backscatter working group are very, very relevant in the Backscatter working group. They don't need to be led by Backscatter working group, but if the Backscatter working group be aware of it, it would be really, really useful for everyone. So the idea is to have some PhD projects or some other projects that are outside of the Backscatter working group that are somehow linked to the Backscatter working group, like supported by the Backscatter working group of that sort. And each branch could basically report on the project's status to some head who basically is to combine that information and to inform the community at large through websites, reports, maybe business code. The idea behind this is to try to do the less amount of work possible. So all the work actually happens outside of that group. And we just direct up, just gather the stuff, we just put it together into a neat report done. I think about this because obviously that kind of work was like, even though they describe it as herding cats, the reality is that they did most of the job, and that's a lot of work to do. And then when they drop for any reason, then there's no more Backscatter working group anymore. So if we can try to save some efforts, it'd be fantastic. No, that doesn't prevent people to actually have specific Backscatter working group projects, such as a special issue or an annual webinar. And then you feel free to co-devise coding to have other people doing it if you want. And then they all go back to the same line to the Backscatter group. And of course, there's some projects which are the Backscatter group wider, such as what we are having here, like as a meeting of defining related branches, which would need to be co-devised or facilitated at that point. But a lot of the actual work in terms of research would be outside of the Backscatter work group. In this view, in this view, like I was thinking about it, like trying to put together the task as I saw it. Just realized a lot of that stuff is really just management and communication. So there's a question: is that just a lot of stuff that we want to do, or do we want to still actually use the Backscatter work will be actually doing the research at the Backscatter work. All of that stuff, you don't need to be a researcher or very knowledgeable about Backscatter to do that sort of stuff. So would that mean that the branch leaders or the Backscatter work group leaders or managers and researchers? And when I'll go really quickly, because it's one I talked about before, is that I've been tracking the remaining pain points along the Backscatter life cycle that I imagine at the sonar manufacturing, data acquisition, environments, data processing, and research level. A lot of that stuff is exactly what everybody's been talking about before. But as I was doing it, I realized there's like a really recurrent theme is this need for standards or benchmark. It's just like it just keeps going on. Like not all problems are problems of lack of standard or benchmark, but a lot of them are. And that means that is that what we want? Is that what the Backscatter group should do? Like be together and say setting standards. And those two questions that just come up is like we already Xavier and Geoffroy failed to get IHO involved with this, but maybe at a stage where we can, because there will be the kind of people who actually that we need the support of to implement this. And if they don't want to, we have sufficient authority and recognition to actually get those things done. And so just to finish, like on the paper I did for the special issue on processing, I proposed at the end that some processing metadata bullet point on what should accompany a mosaic when you produce a mosaic. That looks like a great standard template for what people should produce. Nobody's ever used it. There for 4 years, and I still have seen anyone who produces that sorts of bullet point that lists. But that came from a paper. So there's no reason people would follow this succession of the paper. But if the Backscatter were to say, hey, this is the Backscatter working group 2022 version of the processing of metadata, that convinces people to actually pay us. Another question for that. Thank you very much.